All right, the very last video topic is going to be adding and subtracting the radicals. So to add and subtract radicals, you have to have matching indices and matching radicands. That's what's underneath the radical. So we've done this a little bit before. Go back, for example, really basic. If I have 2 cube roots of 5 plus 3 cube roots of 5, my indices are both 3, so they match. And my radicands are 5, so they match. So I can put them together, and you treat these numbers out front like coefficients. And when I put them together, I'm going to have 5 cube roots of 5. So the only things that add are the coefficients out in front of your matching indice and radicand. So it's pretty straightforward until you get radicands that don't match. The indices are always going to match on these type of problems, but sometimes our radicands are not going to match. If they don't match, it probably wants us to make them match. So I'm doing an example from your book. It's not one of your homework problems, but it's number 40. It's 5 cube roots of 48 minus the cube root of 750. So right away, indices match. That's important. That has to happen. If they don't match, we can't really make them match. We wouldn't give you a problem where it's adding and subtracting where they didn't match. The radicands don't match. If they don't match, and this is an adding and subtracting problem, we want you to try to simplify them to make them match. So I'm going to go back and I'm going to simplify and see what I can find that's in 48 and 750. That's going to give me something common under my index. I'll start over here with 750 because it's the bigger one. So I see 75 and 10, looking for 3 of things. In 10 I see 5 and 2. In 75 there's a 25 and a 3. And in 25 there's 2 5s. So right away I see what I can pull out. There's this group of 3 5s. My index is 5, so I'm looking for 3 of things. So I can pull that 5 out and set it out in front as a single 5. And I cannot get out the 3 and the 2. So those get multiplied back together and put underneath the radical. So I've simplified this down to a 6. So what I really want is this first term with the 48 to end up with a 6. So let's simplify 48 and see what we find in 48. It's even, so I'm going to start with a 2. 2 and 24. In 24 there's a 2. 2 and 12. In 12 there's a 2. 2 and 6. And in 6 there's a 2 and a 3. I'm looking for sets of 3, so I'm going to circle my set of 3. There's 3 2s. That's going to go out in front. I already have a 5 out front, so I need to multiply that 2 by the 5 that I have out front. And then, just like we were hoping, the 2 things that can't come out are this 2 and this 3. They get multiplied back together and put under the radical. So the 5 and the 2 go together for 10 cube roots of 6 minus 5 cube roots of 6. And now it's like terms with matching indices and radicands, which is what has to happen when you add and subtract. I put those together for 5 cube roots of 6. 10 minus 5 gave me that 5 out in front. They're like terms, so we have cube roots of 6.